So my latest project is a hot wire foam cutter made from parts you can buy at Lowe's. It's about 24 inches wide and 24 inches long. It uses a stainless steel wire that is a leader wire I bought from a sporting goods store many years ago. It is about 0.25 millimeter thick. It's a 44-pound wire. I'm using an 1.25 inch pipe on my support so that it doesn't bend and it's more rigid. In other videos I've seen on YouTube, they used like an 1-inch diameter pipe and it bent down whenever they tension the spring. An 1.25 inches is extremely rigid. For my temperature control and my safety, I have a 600 watt dimmer switch. I also have an on-off switch here and a fuse that is resettable, so in case something shorts out, I'm hoping this goes first, or the surge suppressor power strip trips before anything burns up. So as far as the electronics go, it has a power switch and a fuse. It has a 600 watt dimmer switch. It has a transformer that runs off of AC. This transformer is a 3 voltage or 3 stage transformer that I bought at Lowe's. I believe this is for a doorbell. It comes in 8 volts AC at 10 amps, 16 volts at 10 amps, and 24 volts at 20 amps. I tried the 8 volts at 10 amps and I had to crank this dimmer switch all the way up. I mean, it still cut. It cut great, but it really didn't get as hot as you could get it. So I switched it over to the 16 volt and it cuts awesome. It'll even cut through paper that is glued to the foam. But the way I have this wired, I have a 3-wire electrical cord, a hot, a neutral, and then the ground. The hot comes into the switch, goes through the fuse, comes out, goes through the wire nut, goes into the dimmer switch, comes out of the dimmer switch, goes into the transformer, comes out to the white, and goes back into the grid. The on-off switch and fuse, the dimmer switch, and the transformer are all grounded with a ground wire. This is just an old computer cord that I cut the ends off of and attached the ends to the stainless steel wire, attached it to the 16 volt output. This board here is the bottom that holds the PVC support for the stainless steel wire. It's held on with 2 3-inch bolts on this side, and you can take these bolts out and move this around if you really wanted to. And for the attachments here, these are just eye bolts that I screwed a wire onto the end and tighten them down. And it goes on there, and the spring keeps the stainless steel wire tight. This is an 1.5 inch spring used for tensioning the stainless steel wire. This is a 4-inch bolt, 3/8 inch diameter. This is a wing nut. These are rubber washers in between here and here just to hold it, because the wire was not completely square when it was lined up like this. So to square this wire up so it's at 90 degrees, I'm using tongue depressors and putting it in behind here. But I plan to get shims for like putting in doors to do this, so I can shim this up and easily adjust it. So now you see the wires perpendicular to the face of this. For cutting out foam, this is a piece of, I guess, cardstock off the back of a piece of tablet, because I didn't have any cardstock here at the house. So I'm going to go to Dollar Tree or Walmart or someplace and get some 8.5 by 11 cardstock or 8.5 by 14 cardstock, and I can run this through my LaserJet printer. This is a little bit thick, maybe some of the thinner cardstock will work. But anyway, I wanted to print out this little tail section on a plane that I was building. And I cut it out and measured it, made sure it's 10 millimeters. So here's that printed out on cardstock and sprayed Super 77 on the back of this. This is foam with paper removed on both sides, and you can reuse this cardboard or this cardstock without having to spray Super 77 on it each time you want to cut out a piece of foam. So that makes it really excellent for mass producing pieces or making a repair piece for a plane that crashed. So you just stick it on there because the Super 77 is still sticky even after you put it on there and peel it off. Maybe after 3-4 uses you'll have to put more Super 77 on the back of this. And then when these cardstock templates wear out, you just print out more, cut them out with a razor or scissors, spray Super 77 on them, and you have another set of templates ready to go. And you can see how it barely cuts through it right here, so you turn it up. Once you get a nice even flow through the foam, then you know it's hot enough. Not too hot, not too cold. And it should leave a nice shiny cut. I'll show you what it looks like if you don't cut it hot enough. It'll sit there and drag some of the foam with it. It's very difficult to push your wire through there. Okay, so you see here how it kind of drug the foam when it was cutting. That means it's too cold, so turn up your heat. Now we're going to cut this template out. So you see the edges are nice and shiny, and they're really actually kind of hard compared to regular foam board, Dollar Tree or Ross foam board. So that makes good solid gluing surfaces. Peel the template off, and then you have a nice part that you got cut out. I may make these templates in Formica or something like that, but I'm not sure how hard it is to cut those out. But this was my latest project, because this is one thing I really hate, is cutting out the foam and printing out the plans. That's why I want to get a CNC machine, so I can go straight from designing the plans to cutting it out and putting it together and prototyping it.